In class today, we talked about translations as the first type of rigid transformation. Now we're going to talk about reflections. Just a little bit of a background about reflections. They tie a lot to what we know about real life. Figures are reflected about a line called a mirror line, or as your textbook refers to it, a line of reflection. Basically, we have a pre-image that has been reflected over the line that is given. Something that's a little bit interesting, kind of a fun fact, just like with translation and its vectors, the mirror line acts as the perpendicular bisector of the segments between each line. So if you were to see how I put these together, you notice that the green dashed line is always bisected in half. Something else you may notice is that the triangles are equidistant from the mirror line. Pre-image is the same distance as the image is. A quick note, and you may want to pause this first and write it down, and then you can come back and listen to the explanation. When you're reflecting in the coordinate plane, you can reflect a number of different ways. You can reflect over the x-axis, and I showed you what the rule was here. If we're flipping over the x, we're moving up and down, so the y value changes. Or if we're reflecting over the y, we're shifting left and right, that's why the x value changes. Now, something we may not necessarily get to right away is reflecting over a line in the coordinate plane. For instance, if you had a triangle and you wanted to reflect it, you could reflect it over the line y equals 2x. At this point, we're going to focus mostly on x and y axis because that's what's on MSA, and that's about where we're going to be for right now. Just like with translations, reflections start the same way. Just as a side note, I keep using triangles. They're not necessarily always triangles, but I kind of like that we're using triangles since we just learned about the specific types of them. First things first, it's the same triangle that was in our lesson earlier on translations. Pause the video, take a second, and plot the triangle. At this point, we're not doing translations, we're actually doing a reflection. And the reflection we're going to do is over the y-axis. Oftentimes, students get confused and think if something's over the y, that a figure is actually moving up and down. But if we look at the y-axis as our mirror line, it's much like the example we had earlier. When we reflect over the y-axis, what happens is that each x value changes to the opposite. So instead of negative 3, 2, we now have positive 3, 2. Instead of negative 6, 2, we now have positive 6, 2. Instead of negative 3, 6, positive 3, 6. When you go through and you find those new points, and I have them listed here, when you go through and you do that, you notice that your triangle that you have has just been flipped. We also notice that the points that are new are equidistant from the y-axis. For instance, point A is 3 points away from the y-axis, and then this point here is also 3 away. The question you want to ask yourself for these problems are, is each new coordinate equidistant from the original coordinate? That's our way to check our work and make sure that we know we're correct. Example 2 is the same triangle that we saw as our second example with our translation. Take a second, pause the video, and plot the triangle that was described. This time we're going to reflect over the x-axis. What's interesting is the last triangle we had was completely, and I'll go back to the screen, was completely isolated in one quadrant. This triangle here is in all 4 quadrants, so when we actually have our graphing completed, it's not going to look exactly the same. When we reflect over the x-axis, we're actually moving up and down. Therefore, if we look at our rule, all of the y values change. I went ahead and I changed all of my y values to the opposite. One thing I just want to make sure we notice is we only changed the y, so things didn't change necessarily for the x. If ever there is a 0, remember, 0 is not positive or negative, it's neutral. So our new triangle that we're going to have is located at negative 3, positive 2, 0, negative 4, and 3, positive 2. If I were to connect these lines, that go right here, you would notice that the triangle is completely flipped over itself. And again, you want to ask yourself, is it equidistant from the original coordinates, meaning really from the x-axis? So I notice that point B is 4 away, point B prime is also 4 away. Take a minute and look at the Edmodo website and see what kinds of things you can do to practice this for tomorrow.